Okay, here we are. We're going to do Chapter 4, Problem 17. So let's go ahead and label that. Okay, this is one of the problems where you have to pay special attention to what the problem's actually telling you. Focus on the words quite a bit and then move on to the numbers. Frandeck Company manufactures, assembles, and rebuilds material handling equipment used in warehouses and distribution centers. One product, called LiftMaster, is assembled for 4 components: a frame, a motor, 2 supports, and a metal strap. Frandeck's production schedule calls for 5,000 LiftMasters to be made next month. Frandeck purchases the motors from an outside supplier. That's important. But the frame, supports, and straps may be either manufactured by the company or purchased from an outside supplier. Manufacturing and purchasing costs per unit are shown. Very important. Those items may be purchased, may be manufactured, or purchased from the outside. 3 departments are involved in the production of these components. The time in minutes per unit required to process each component in each department and the available capacity in hours for each of the 3 departments are as follows. A. Formulate and solve a linear programming model for this make or buy application. How many of each component should be manufactured and how many should be purchased? And B. What is the total cost of the manufacturing and purchasing plan? Okay, so we're trying to find the total cost. B, that'll be our red cell. And A will be how many do we manufacture and how many do we purchase, is what it's asking us there. That's the make or buy application. So let's go ahead and set up the problem. First thing, we want to import all of these items. Component. Can't spell. There we go. Component. We have the frame, support, strap. And this will be the manufacturing cost. We'll just call it man cost, per cost. Okay, and then we're just going to go ahead and plug this stuff. That's from the first table. Let's go ahead and put those numbers in. 38, 11.5, and 6.5. Here we have 51, 15, 7.5. And let's put the items in for the next table as well. We know we're going to need them. When we put them next to each other, it'll just all seem to fit a little better. These are the time requirements: milling, shaping, and these numbers are given to us as well. 3.5, 1.3, 0.8, and they also give us a capacity in hours. So let's just tack that on, and we'll come over here and hit capacity. Of course, that doesn't apply to the cost, it just applies to the cutting, milling, and shaping. 2.2, 1.7, nothing, and 420. There's no milling involved with the straps, as you can see. Here we have 3.1. This is all just data entry, all given to us. 7 and 680. Okay, now we have to actually create something. So what we know, we need to manufacture and purchase certain amounts. So let's go ahead and enter that in. We know we need to do, can't type and talk at the same time. We need to manufacture and purchase these items. We need to manufacture or purchase, I should say. So these are yellow cells. It kind of tells us that. We also have to divide things up based on the total number of units. Okay, this is important because you need one. I'm going to put total per unit. When reading the problem, you see that you need one strap, 2 supports. I'm sorry. Yeah, 1 frame, 2 supports, and 1 strap. So that's from the problem. That's often overlooked. And then we need to find out how many total are going to be made. Total made. And of course, this total made of each. Total frames, total supports, total straps. So we're going to multiply how many were manufactured. So this is equals G4 plus H4. Okay? We're just adding these up right now. These are the total number made and purchased. Now the reason for that is because it says we have to make 5,000 of these. So at some point we need to get to 5,000, and this will tell us how many total units we have. And let's do now total cost. So total cost will equal the total number manufactured times the manufacturing cost, which is given to us, plus the total number purchased times the purchasing cost. Drag those down. And then we're going to sum these up, and this will give us our total cost. And so let's just do a sum function. Okay. Total cost. So now we can see if we enter something in here, we'll enter in, say, 2,000. We can see that the sheet works. See, those aren't the real answers, that's just numbers to make sure that the sheet works. And it's using the cost we have. We have the cost, we have how many, we have the total number made. That could be titled something differently. That's the total made, and that gives us the total cost. Alright, let's zero these out. And now we need to deal with our constraints, which is that second table, the capacities. So we have manufacturing capacities that we need to worry about. So let's go ahead and set up constraints. Oh, we also know we have a production requirement. I didn't put that in. Production requirement. And that's 5,000. Okay, constraints. First, we have cutting capacity. So it tells us that our cutting capacity is 350 right here. So I'm just going to reference that cell, equals 350. Okay. And while we're at it, we're just going to start these others as well. Milling capacity and shaping. I'm going to do all of these at once just to make life easier. And we're just going to reference these. Milling capacity is 420. And you know what though? I'm going to make things a little more confusing, and I'm going to do I'm going to convert those to minutes, because those capacities are in hours, and I'm going to do it in minutes. Capacity in minutes. Let's just do this very quickly. It's going to multiply this times 60 and drag that over. Now I'm going to reference those. Just seemed to make a little more sense to me. So we did those in minutes, and so these are the capacities, these are the upper limits. So the mouth is always swallowing the upper limit. So we'll drag those down. And we now have to set up, it has to be greater than the total amount of cutting, milling, and shaping that was actually done. These are capacities, and these have to be greater than what you're actually, how much cutting, milling, and shaping you actually do. So I'm just going to put up here and say total use, and we're going to calculate that right there. So we have to figure out a formula for total, how much cutting, shaping, and milling is actually being done. So we're going to multiply the cutting of the frame, and that's going to be times G4, that's how many we actually manufacture, plus G5 should say plus D5 times G5 plus D6 times G6. So that'll tell us how much we actually did. Remember, we don't need it for purchase since somebody else is doing the cutting. All right. Now we have to do the same thing here. We're going to go E4 times G4 plus E5 times G5. So we're going to need a plus there. And we're not doing the bottom one, so there's nothing here. There's nothing in this cell, so it's going to hit return. There's nothing in that cell there. So in the last one, we're going to go F4 times G4 plus F5 times G5 plus 6 times G6. All right. Now that's giving us the total amount of cutting, milling, and shaping we've done. So those numbers will fit in real nicely right here. Equals D9. Remember, since there's nothing in those yellow cells, this is all going to be empty. But if we want to start plugging stuff in, you could see that it works. All right. And that should all be in minutes at this point. Because everything, sorry, technical problem there. Everything should line up well at this point. Okay, next one, you need to go by how many are needed. How many frames are needed, how many supports are needed, and how many straps are needed. Because you have a certain, that'll guarantee that you have 5,000 items. And this is where this per unit comes into play. Okay, so we're going to go with how many frames, how many supports, how many straps. Okay. To figure out how many we need of each, we're simply going to multiply the total production requirement times the total, how many per unit. So we're going to need 5,000. I'm going to do a little trick here and just lock this one into place so we can drag and drop. Okay. So we're going to need 5,000 frames, 10,000 supports, and 5,000 straps. Now you probably could have done that in your head, but it's good to go ahead and go through the process. And that is equal, because we need exactly that many. And this will just correspond to the total number made right here. So this will guarantee that we have 5,000. Just going to drag that down. Okay, so you can see that this matches the total number made over there. Now, believe it or not, we're actually done setting up our model. We've constrained it so that we meet the cutting, milling, and shaping requirements, and we have also set it so that everything will equal out to 5,000. So let's go to Solver, and we'll set the red cell, and we're going to minimize cost, And we're going to highlight the yellow cells there. Before I forget, simplex. We're going to add our constraints. Those three are greater than or equal to those three. And those three are equal to those three. Looks good. Solve. Found a solution. And there we have it. Now Solver's giving me a little hiccup right here. That's okay. Well, you can just round those off. That is the correct answer. 5,026.92, 0.7308. And if you don't like that, you can always go over here and format the cells. Oops. I didn't select the one I wanted. And set the decimal places to 0, and that's how it goes. Okay, well, there we have it. The tricky points here is to make sure to convert in minutes. Okay, and I think that does it.